So January 2021 paper, first two questions are actually recorded. So I will start with question 3. We have the azo dyes, which is organol brown, can be made from a benzene, C6H6, as you can see here. The reaction scheme is there. First, we have a benzene. We convert it to a nitrobenzene. How it can be converted into nitrobenzene by using a mixture 50% nitric acid and sulfuric acid concentration. Then it convert into phenylamine. We can use tin and hydrochloric acid to convert into phenylamine. Then a phenylamine is converted into benzyl chloride, benzonyl chloride. That is by using sodium nitrate, and the temperature should be below 10, then it will happen. Otherwise, it will decompose. And then there's a coupling reaction, like two benzene rings are linked by a nitrogen. That is called a coupling. As a result, it will form the final product. Um, in a preparation of a nitrobenzene, state the reflux like a mixture is warm at 55 under reflux for 45 minutes, and the reaction mix stirred thoroughly. What is the reason for this practice? So the main reason why we want to do this, like as you can see, it also depends on the first we have a benzene and then we have a nitrobenzene. So the main reason for reflux for a longer period of a time, benzene reactions are not like a violent reaction. It reacts at high temperature. And so and it allow the reaction to complete or complete mixture, or we are ensuring that all of the benzene will react. So to make sure that all benzene will react, that's why it is done. Draw a diagram. Apparatus used to warm a reflux condenser. You have to draw here. Vertical condenser and round bottom flask. And mention heat and label the apparatus. Suggest why the reaction mixture is stirred continuously. So, and anti-bumpering granules you can also add. So main reason, because nitric acid and sulfuric acid are aqueous, whereas benzene is a organic compound. So the two substances are immiscible. That's why we have to mix them thoroughly. So that's why we have to stir. So because the two substances have a different nature, one is organic, another one is aqueous. So they don't mix with each other. That's why we have to continuously stir so that they mix thoroughly. Identify suitable drying agent. Normally, like drying agent, it should be unreactive and solid. So we normally use sodium sulfate as a drying agent, anhydrous sodium sulfate. Calcium chloride can also be used as a drying agent. Then the nitrobenzene is reduced to phenyl. Phenylamine then react with nitrous acid at temperatures 0 to 10. And nitrous acid form reacted using nitrous acid is formed in reaction using a sodium nitrate and hydrochloric acid. State why nitrous acid is generated, because and nitrous acid is generated in a reaction instead of being, because what happened, it is unstable compound. It can decompose by the light, the nitrous acid. That like, so it is difficult to store. That's the main reason we prepare when we need. It's not there. We just prepare when we need. So why nitrous? You can mention it's an unstable compound, can decompose easily. That's why the supplier is not providing this nitrous acid. Explain why the temperature of a reaction mixture between a phenylamine and the nitrous acid must neither lower than 0 or above 10. So what will happen if it is less than 0, the temperature is too slow, like too low for a reaction to happen. And if it is above 10, then the disonium compound can decompose. That's why it should be between 0 and 10. And how we can maintain this temperature? You can use an ice bath. Reaction of disonium compound with alkaline solution is there, produce a solid azodine. The impure organol brown is dissolved in a minimum volume of a hot solvent. Why we use a minimum volume of a hot solvent? So the main reason is like to make a saturated solution. So that's why impure organol is dissolved in a minimum. Otherwise, if volume of a solvent, if you take a hot solvent, a large volume, then when you do a recrystallization, not all may not appear. That's why we take a minimum volume as much we can, so that when we do crystallization, this organol brown or the crystals will appear. The solution is filtered. So why? This is a common question in paper 6. They ask. So why a minimum volume of a hot solvent is used? So as I mentioned, just to make sure that when we do recrystallization, the maximum amount will extract. Otherwise, if you use a large volume and when you do recrystallization, the maximum amount will not form. Why the preheated funnel is used in step 2? So it is just preventing the cooling down of a solution. Otherwise, the crystals might, if the solution is cooled down, the crystals might start to form during filtration and that will left on the filter paper. And give a reason for each filtration step 2. Step 2, a Buchnell funnel is used. So what is solution is cooled and the filter is that is reduced under a filtration under a high reduced pressure. Main thing is to remove the insoluble impurities, the impurities which does not dissolve. And step 4, step 3, sorry, the solution is filtered through hot. So what is the reason for this? To remove insoluble, and solution is cooled and filtered using a Buchner funnel. So this is to remove the solid, because the solid which is left on the filter paper when we are using a Buchner funnel, so that will be the organol brown. So this purpose of this filtration is to remove the soluble impurities, and purpose of the first filtration is to remove the insoluble impurities. Give a possible reason why it is preferred to dry a solid in desiccator. So usually the substance might decompose on heating. So we prefer to use desiccator for that. And the melting temperature of a recrystallized organol brown is measured and check is state what would you observe a sample was pure. So it will reduce the range of a melting point or it will have a sharp melting point. You can mention a small range because still practically it's not like 100% pure. So there is a differences there. So you can say a very small range in the range about 2 degrees plus minus, like if it was a pure was like example 109, so it might be 111 or it might be 113, 107. So small range will be there if you have a pure substance, or you can also say a sharp melting point. Is it clear, this question?